Welcome. In the previous e-learning module, I had demonstrated how to check sheet 1 of the assembly drawing and correct the assembly drawing if any mistakes were found. In this e-learning module, I shall demonstrate and make you understand how to check sheet 2 of the assembly drawing and then correct the assembly drawing if any mistakes are found. Click on sheet 2. Right-click on section BB and pick Activate View. Hide the axis. The hatching of the strip guide plates is wide. Let's make them narrow. Double-click on the hatch of the strip guide plate. Update the hatch angle to 45 degrees and the hatch pitch to 1 mm. Double-click on the hatch of the strip guide plate. Update the hatch angle to 45 degrees and the hatch pitch to 1 mm. Double-click on the hatch of the strip pusher. Update the hatch angle to 135 degrees and the hatch pitch to 1 mm. Observe something is missing in the strip pusher. I have forgotten to assemble the stopper pin to the strip pusher. Swap the window to the die assembly. Observe the stopper pinhole is also not in the correct position. Measure the distance between the center of the stopper pinhole and the center of the strip pusher. The measured distance is 20 mm. Right-click on the strip guide plate and open it in the new window. Double-click on the stopper pinhole. Update the positioning dimension from 72 mm to 72 mm plus 20 mm. Local update the inertia volume. Set the view to fit all in. Save the strip guide plate. Close the strip guide plate. Observe the stopper pinhole is aligned with the center of the strip pusher. Now let's assemble the stopper pin. Measure the diameter of the stopper pinhole. The measured diameter is 5 mm. Measure the distance between the top surface of the die plate and the strip guide plate's top surface. The measured distance is 12 mm. Click on the catalog browser. Search for the die 5 dowel pin. Check for the available lengths. There are two suitable lengths, 10 mm and 12 mm. Let's use the 10 mm length pin to be inside the strip guide plate when assembled. Double-click on the 10 mm length pin. Click on OK. Close the catalog browser. Apply a coincidence constraint between the dowel pin's axis and the stopper pinhole axis on the strip guide plate. Apply a contact constraint between the die plate's top surface and the dowel pin's bottom surface. Update the assembly. Pick the sectioning command. Pick Y-axis as the normal constraint. Pick volume cut on the Result tab. Observe the dowel pin assembled as a stopper pin preventing the strip pusher from moving forward. Right-click on the dowel pin and open it in the new window. Click on the Apply Material command. Pick steel material from the Material Library window. Pick the dowel pin. Click on Apply Material and then OK. Now let's calculate the mass properties. Click on the Measure Inertia command. Pick the dowel pin. Make sure the Keep Measure has been selected. Click on OK. Now let's add the nomenclature to the dowel pin. Right-click on the dowel pin and pick Properties. On the Product tab, enter nomenclature as dowel pin die 5 into 10L. Click on Define Other Properties. Create a new parameter of type mass. Click on OK. Let's create a formula to equal the mass inertia parameter to the mass parameter. Click on the Formula command. Enter mass as the filter name. Click on the first parameter, then click on Add Formula. Pick mass on the members of parameter. Observe both the mass parameters are displayed in the members of mass. Double-click on the inertia volume mass parameter. Click OK. Observe the formula is added. The first mass parameter is equal to the inertia volume mass parameter. Click on Apply and then OK. Save the dowel pin. A similar part name exists in the session. So, add a suffix of _1. Click on Save. Swap the window to the drawing. Update the drawing. Observe the pin that appeared in the drawing. Right-click on the section View BB and pick Overload Properties. Pick the dowel pin in the Characteristics window. Then click Edit. Uncheck the Cut in Section Views. Click on Apply and then OK. Let's check if the dowel pin appeared in the bill of material. Click on Sheet 1. Update the drawing. Observe the dowel pin that appeared in the bill of material. Click on Sheet 2. Now let's generate the balloon for the dowel pin. Make sure Section BB is the active view. Click on Insert, Generation, and then Balloon Generation. Observe many balloons are generated. Right-click on balloon number 33 and delete the positional link. Delete all unwanted balloons. Position the balloon number 33. Add a breakpoint. Position the breakpoint and the arrowhead suitably. Right-click on the section View BB and pick Overload Properties. Pick the blanking punch in the Characteristics window. Then click Edit. Uncheck the Cut in Section Views. Click on Apply and then OK. Lengthen the axis of the fasteners to indicate the length of the fasteners. Hold the Control button on the keyboard to lengthen the axis in a single direction. Observe the die opening is good. Right-click on the section View BB and pick Properties. Uncheck the Display View Frame. Click on Apply and then OK. Now let's check Section View CC. Lengthen the axis of the fasteners to indicate the length of the fasteners and fastener holes. Hold the Control button on the keyboard to lengthen the axis in a single direction. Update the hatch angle of the lifting hook to 45 degrees and the hatch pitch to 2 mm. As the profile of section CC does not pass through these lifting hooks, let's not cut them in section. Right-click on the section View CC and pick Activate View. Right-click on the section View CC and pick Overload Properties. Pick the lifting hooks in the Characteristics window. Then click Edit. Uncheck the Cut in Section Views. Click on Apply and then OK. Hide the axis. Update the hatch angle of the lifting hook to 45 degrees and the hatch pitch to 2 mm. Observe one of the hooks is still cut in section. Right-click on the section View CC and pick Overload Properties. Pick the lifting hook in the Characteristics window. Then click Edit. Uncheck the Cut in Section Views. Click on Apply and then OK. Right-click on the section View CC and pick Properties. Uncheck the Display View Frame. Click on Apply and then OK. Now let's check section View DD. Lengthen the axis of the fasteners to indicate the length of the fasteners and fastener holes. Hold the Control button on the keyboard to lengthen the axis in a single direction. Hide or delete unnecessary axis. Update the hatch angle of the strip support plate to 135 degrees and the hatch pitch to 1 mm. Right-click on the section View DD and pick Activate View. Hide the axis. Right-click on the section View DD and pick Properties. Uncheck the Display View Frame. Click on Apply and then OK. Now let's check the punch assembly view. Right-click on the punch assembly view and pick Activate View. Let's hide the fillet lines. Right-click on the punch assembly view and pick Properties. Uncheck the fillets. Click on Apply and then OK. Right-click on the punch assembly view and pick Properties. Uncheck the Display View Frame. Click on Apply and then OK. Now let's check the die assembly view. Right-click on the die assembly view and pick Activate View. Hide the axis. Right-click on the die assembly view and pick Properties. Uncheck the Display View Frame. Click on Apply and then OK. Set the view to fit all in. Save the drawing. Click on File, Save All, to save all the modified files in session. With this, we have successfully learned how to check the assembly drawing. That's all in this e-learning module. Thanks.